Hey. All right, hey, what's up, everybody? It's Corbus here, ready to teach a lesson. Hope y'all are all doing really well today. All right, let's just go pretend that the camera's not there. Okay, all right, just go, everybody, let's go. All right, so they think I'm so weird. Let's do the warm up. So these types of problems right here, we got two problems. Practicing what we talked about yesterday with geometric sequences. Okay, two very common problems. So make sure you take good notes and know how to do these two problems. Okay. All right. So the first one says find the 10th term. So if you see a problem just like this, I'm not going to tell you whether it's geometric or arithmetic. You're going to have to decide that on your own. But what kind of sequence is this? What's the pattern? We're going negative 48, 12, negative 3. Yeah, we're dividing by negative 4, but so in geometric we don't divide. It has to be multiplying by something. Yeah, we're timesing by or multiplying by negative 1/4. That's my rate. I'm multiplying by negative 1/4. So that's geometric. Okay, if it's geometric, that means we need to do the explicit formula for a geometric sequence. Anytime you're trying to find any number term, use explicit. Since it's a geometric, we're going to use the equation a sub n equals my first term times my rate to the n minus 1 power. Okay. Anytime you need to find any other term, use one of your explicit formulas. Geometric, so use that. And since we're trying to find our 10th term, we need to know really three numbers. This, and this. Our a sub 1, our rate, and our n value. Okay. As long as we know that, we have our answer. Okay. I'm finding my 10th term. What's my first number in the sequence? Negative 48. What's my rate we just talked about? Negative 1/4. And n minus 1. What's my n value? 10 minus 1. All right, so this is the formula. Just type that in exactly like you see in the calculator. Somebody to read off what their calculator is saying right now. Like what? Because I want to talk about what that answer is. 1.83 something e negative 4, right? All right, yeah. So let's refresh yourself on what that means. If you wrote this down as your answer on the test, I'm totally cool with that. I'll accept that. That's fine. Okay, just make sure you include the e negative 4. But what that means is it's basically telling you how to move your decimal place. If it's negative 4, it means move your decimal place 1, 2, 3, 4 spaces. So really my final answer is 0.000183. Okay. And that should make sense. I mean, you're multiplying by a fourth each time. And you can even see it's going negative 48, 12, negative 3. It's going to keep getting smaller and smaller. It makes sense that it's that small of a decimal. And with geometric sequences and series, it's kind of hard to go too far down the list because it's an exponential growth. I mean, if it's getting bigger and bigger, that number is going to be huge. If it's getting smaller and smaller, that number will eventually get really small. So I can't really take it too far in the series. Does that make sense? Good. The next one, we had a problem like this yesterday. It says for the given sequence, we got a sub n equals a sub n minus 1 times negative 2. All right, what is this type of formula called here? We have our explicit formula. This is called recursive. Yeah. This is our recursive formula. And so the only formulas we have so far is the recursive and explicit formulas for geometric and arithmetic. That's 4 formulas. The explicit is the most important. The recursive is not really as important. The only questions I can ask on that is really write the recursive formula. And what else? What is it useful for? Yeah, it tells us what our R value is. Okay? So in this particular problem, our rate is negative 2. That's our pattern. We're multiplying by negative 2 each time. So given our R value and given our 4th term, it wants us to know what our first term is, a sub 1. Okay? Again, it's just asking for a number in the sequence. So if it's ever asking for any nth term, your explicit formula is your best bet. Okay? So, how can I set that up? How can I solve this problem? What do we got? So, this right here, these two numbers right here, are helpful for telling you two variables. It gives you an n value, and it gives you an a sub n value. Okay, it's giving you terms you can plug in to work backwards in your explicit formula. So what we have is our a sub n value, or a sub 4, is negative 24 equals. The first term is what I'm looking for. The rate we just found in the problem is negative 2. And n minus 1 would be 4 minus 1. Okay? So look at the explicit formula. Look what all variables are given to you. If you have enough to solve for a sub 4, yeah, you're good. I recommend simplifying down that piece first. It's negative 2 to the third power, I guess. Negative 8?
Yeah.
So a sub 1 times negative 8 equals negative 24. And then we divide both sides by negative 8. I'm getting a sub 1 equals... Yeah. What do you think? Not too bad, right? Make sense? So I would maybe star number 2. That's a very common question I like to ask. Maybe have the good notes come back to on this. That is. All right. So today's lesson, we're going to talk about today. We talked about geometric sequences. We talked about arithmetic sequences. We're bringing in a new term today. It's called series. Okay. So when I'm talking about sequences, I'm talking about a list of numbers, so separated by commas, can't even talk today, where they follow a certain pattern. With series, I'm just going to be adding all those numbers together. So it's the sum of the terms. For arithmetic series, it's the sum of the terms in the arithmetic sequence. So basically, you're replacing those commas with adding symbols, plus signs. Okay. Okay, so whenever we're like evaluating a series, we're actually finding an answer. We're actually going to be summing all of these up. So like if my pattern is 1, 3, 5, 7, 9, that arithmetic pattern, I go all the way to like the 1,000th number, I have a way to be able to add all those numbers up. Okay, there's a formula given for that. And it's this one right here. Okay, so star that, highlight that. That's our next formula for today. And what this is saying is that S sub n is the sum of a finite set of terms. Meaning, like if I say S sub 100, it means find the sum of the first 100 terms in the series. Okay. Now, and all these other variables, a sub 1 is still your first term. N in this case is the number of terms. Okay, so that's a little bit different. It's the number of terms that we're trying to add up. So if I say the sum of the first 100 terms, n is 100. But a sub n in this case, that's going to represent your last term. So basically what the formula says is do your first plus your last, divide by 2, so basically average them, and then multiply by 10. And that will tell you the sum of any series. Okay? That's it. Let's look at an example. All right, it says we have a sequence, so we have 9 numbers here. We have a sequence that only has 9 terms. Find the sum of the related series. All right, so I realize we're given the first 3, and it's not hard to find the 6 remaining numbers and just add them up. I get it, that's fine. But on a test, I'm probably going to say find the sum of the first, 100 terms, okay? So it's good to know the form. All right, so talking about arithmetic, just remember, and maybe have this in the back of your mind, that the sum is just n over 2 times my first term plus my last, okay? In order to do this formula, in order to evaluate a series, all we need is just 3 variables. We need to know our n value, we need to know our first term, and our last term. That's it. All right, let's start off with, okay, what's our n value? 9. Yeah, we're finding the sum of the first 9 terms, 9. What is our first value, a sub 1? Negative 3. All right, a sub n represents my last term. So which term am I looking for? The 9th term. I'm looking for the 9th number, a sub 9. Well, how do I figure out what my 9th term is? You got to use your explicit formula. Anytime I need to find any nth term, use our explicit. I know if I'm my 9th term. We've been using that formula for a while now. Remember, it's our first term, negative 3, plus n minus 1, which in this case n is 9. Apologize. And then times our common difference. What's our common difference in this case? Yeah, it's plus 4. What does that equal? 29? Alright, so I have my first term as -3, I have my last term as 29. Just plug all those bad boys into your formula and you're good. So if I want to know the sum of the first 9 terms, it's just equal to, well, 9 divided by 2. That was my first term, which is -3, plus my last term, 29. And that'll evaluate the series for you. That'll find that sum. Yeah, I don't know. 117? Yeah. Sweet. Now what do you think of that? Let's do that, okay? Okay, so you see the difference between what a sequence is and a series. This right here is a sequence. A series would be adding them up. Okay? Now, that was an example of arithmetic series. Geometric series is the same exact definition, same exact thing. It's just we're summing up the terms and now in a geometric sequence. Okay, that's all that means. So we're going to take our pattern that's geometric, meaning that they're all following some type of rate. And this right here is the formula that we would use to figure out the sum of a finite amount of terms. If I say find the sum of the first 20 terms, we can use this formula here. And this formula may look scarier, but it's not as bad because we don't need to know our last term. All we need to know is our first term, our rate, and our end value. Okay? Oh, do this for me. Just add a parentheses right here around this R value. Sometimes that messes you all up, especially raising it to a power. Just make sure you put that parentheses. S sub n still means the same thing. A sub 1 is still our first term. R is our rate. And n is the number of terms. All right, questions on that? So just make sure you star this formula, know this formula. That's how we do it. Let's give you a second around that now. All right, so in my actual class, 10 minutes has just passed. So let's go through this problem right here. The sequence has 6 terms. All right, find the sum of the related series. So when I do -5 plus 15 plus -45 and on. Okay. Now I realize it's only 3 terms, and I can find the missing 3 terms and add those 6 terms together. It's not hard. But let's just practice the formula, okay? Remember the formula, if I want to find the sum, Sm, is equal to my first term, 1 minus, put that rate in parentheses, all over 1 minus r. Okay? So, we only need to identify a few things here. We need to identify our first value, which everybody always gets. We need to evaluate our r value and then our n. Those aren't too bad. What's my first value? -5. What's my rate? What am I multiplying by? Yep. Multiplying by -3. What's my n? 6. Alright, so if I'm doing this problem, just plug those 3 numbers in. So I do S sub, if I'm trying to figure out the sum of the first 6 terms, S sub 6 is -5. 1 minus my rate, which is -3. To the 6th power, all over 1 minus -3, or 1 plus 3, yeah. And type that in the calculator exactly as you see it, exactly as I wrote it, okay? Parentheses and all, put it in the fraction, yeah. Yeah, who got 9 and 10? Okay, not 90, 9, 10, there you go. Wait. Here, let's show it the calculator real fast. Oh, and for those watching the video, try it on your own. So I think both of those formulas are great. But I have an alternative approach that I think is better, and I'll let you decide which ones you want to use rather than formulas or what I'm about to show you. I prefer what I'm about to show you more. It's called summation symbol. It's called summation notation, sigma notation. So you can do everything we just did using this fancy symbol. This is called sigma. Okay, this little Greek letter here. It's called sigma. Oh my God. You can use this to write any answer, any series. Okay. Let's talk about what this is saying. A little confusing. Let's talk about what it's saying. Let's talk about how to read this. Okay. What this is saying, how this is read. This means take the sum of a bunch of numbers. Well, what numbers? All right, this is saying go from your first term. This one right here means your first term. And the number on top means your last term. So basically I'm saying go from your first term to your third term. Okay, so 1, 2, 3. Not the value of the term, but the number term in the sequence. So you're going from your first term to your third term. Now, what's in parentheses of the sigma notation? This is just your pattern. Okay? This is telling you what pattern you're following, what sequence you're going to have. And this formula inside the parentheses will always be your explicit formula. So just by looking at this equation here, 5n plus 1, what kind of explicit formula is that? Arithmetic or geometric? Arithmetic. This is a linear equation. Remember, linear equations are arithmetic equations. 5n plus 1 is just linear. All right, so we're just going to do this in the calculator, but I want you to understand what the calculator is doing for us. It's doing the pattern for every term between 1 and 3 and then adding up those numbers. So what the calculator is doing is it's plugging 1 in for n. So that's like 5 times 1 plus 1. And it's plugging every number in for n all the way up to 3. So it'll be 5 times 2 plus 1, 5 times 3 plus 1. And it's going to keep doing that until you get to your last term, and it's adding them up for you. So it's doing that whole long process, but in the calculator. Okay, so you don't have to do the formula. Let's see, that's right. That's 6, that's 11, and 16. And it's adding those together. So it's a shortcut. And the reason I like this is because you don't need to know the formula. What you need to know is just how to write the explicit formula, which is what we've been practicing the last 2 days. What's that equal? Thank you. Okay. So let's just answer these questions. How many terms are in the series? 3. There's only 3 terms in this series. 1, 2, and 3. What are the first and last terms? 6, 16. Okay? So, like, these are the 3 numbers that are in this list. They follow the pattern that we're adding 5 each time. It's arithmetic. And if it says to evaluate the series, this means find the sum, which we did, 33. I love this. I want us to be able to create this on our own and not have to use those formulas. But it's up to you entirely. If you like the formulas better, do it. Questions on that? All right, let's look at another one. Okay, so let's talk about how we interpret this. What this sigma notation is saying. It's saying go from n equals 2 to 7 using the pattern 5 times 2 to the n minus 1 power. So let me first ask this. How many terms are in the series? Nice, 6. Because think about it. You're going from your second term to your 7th term. That's saying do your 2nd, 3rd, 4th, 5th, 6th, and 7th. That's 1, 2, 3, 4, 5, 6 numbers. That's 6. What if I want to know my first and last terms? What do I plug in to find my first term? 2. It's the first number. This just tells you where you're starting. That's all that means. So we would do 5 times 2 to the 2 minus 1 power, which I believe is 10. And a little side note here, this is the explicit formula. What kind of explicit formula? Yeah, it's a geometric explicit. Okay, because it is that formula we have. A sub 1 times our n value, or r value to the n minus 1 power. All right, if I want my last term, what do I plug in? 7. We're going to the 7th term, so we plug 7 in for n. That's 5 times 2 to the 7 minus 1 power. Which is equal to, what is it? 640, thank you. Okay, 320 it is. Is it 320 though? I can't remember. So 2 to the 6 times 5. All right. All right, if I want to evaluate the series, okay, we can do all 6 terms like we did before. We can plug in 2, then 3, then 4, and then add them all up. That's what the longhand is, but the calculator will do this for us, okay? So let's do this in the calculator. And then for those that are watching the video, to do it in the calculator, you're just going to go to math, okay? You're going to scroll all the way down to option number 0, okay? What it looks like when you press enter, it has that summation symbol, that sigma notation in it. It's going to be a blank sigma notation. Okay? And all you have to do is just plug in all the numbers that you see in the original sigma. Okay? So for a variable, we plug in x. For that first space, well, that's a 2 in the original sigma. Okay, we're going to our 7th term, so we plug 7 in there. And whatever our equation is, just what's going to go in this parentheses. So right here, we're going to plug in 5 times 2 to the x minus 1 power. Okay. Then it'll give you the same answer. Well, it'll give us whatever our answer is. Okay. So let's practice that. Now, so I'm getting 630 whenever I evaluate that. Okay, 630 is the answer. Now that's great that you know how to read this and interpret this, but what I think is most useful is if we go back to these problems we did earlier. So this first one right here, this first one with the 9 terms, we solved it by doing our formula. We got 117. That's great. If you like doing the formula, do it. But I prefer sigma notation. So what I'm saying is we can write, I want us to be good at writing this list of numbers in sigma notation. So let's think about how to do that. Let's start by writing your little e. My e's are always ugly. But if I'm writing e, you got to put something on the bottom and top. And if we're ever writing it from a list of numbers, what term are we always starting with? Yeah, n equals 1. We're starting with our first term. In this particular example, what term are we going to? The 9th term. All right, so we're going from our first term into our 9th term. Now remember what I said, inside sigma notation, you always put the explicit. Since this is an arithmetic pattern, we put the explicit formula for arithmetic sequences, which we've been practicing, and we already wrote it right here, basically. It's our first term, -3, plus n minus 1. And because n's our variable, we just leave that as n. And then what was our difference? 4. So all I had to type into this was just my first to 9th term, and all I had to know was to write my explicit formula. And that's going to equal the same thing as doing the actual formula, which is 117. And I prefer that so much better because it requires me not to know an additional formula, just know the explicit. Make sense? Here, try it with this next example. Summation, and you're going to have it as n approaches some number, n equals some number on top, and in parentheses is going to be our geometric explicit because the pattern is multiplying by -3. Who's got it? How do we write it? N equals 1, 2. We're doing the first term to the 6th term. Now all I need to know is just how to write my geometric explicit, which we've done enough practice with. So what's my geometric explicit? my first term, negative 5, times my rate, which is negative 3, to the n minus 1. All I did was my geometric explicit, and now it's going to do that sum for me, and it ends up giving us the same thing. What do you think? Hopefully everybody enjoyed the video. Good luck. If you need anything, you know where I'm at. Say goodbye, class.
Yeah.